All right, so welcome to the video for lesson number 13 on essentially finding sinusoidal functions in our calculators. So one of the things we have to be able to do is identify what the period of the function is by looking at some data or the context of the problem, and then being able to type some stuff in the calculator. And for those of you that were a little bit confused today with the calculator buttons, or didn't have your calculator today, or just maybe missed something, I am going to show you on the calculator right here through this video, so just keep that in mind. So first thing we have to do is identify what the period is, because I can't do anything without knowing what the period is going to be for the function. So reading through this question, it's talking about the number of daylight as a function of time, and it says time is in terms of days. Since it is in terms of days, I know that the period, what the heck, the period is going to be 365 days. Because it looks like I'm starting at 4 and around 350 I'm back near 4. I know it seems like 350 might be the period, but since we're talking about a year, I would go with 365. It just makes more sense. Okay, it looks like about halfway through is where I see my maximum, somewhere around there. So without actually even doing this in the calculator, I kind of already know it's going to look something like an upside down cosine curve or a negative cosine curve. Now, because we're using a sinusoidal function in our calculator, remember, I'm not going to be able to represent this with cosine. The calculator always represents everything as sine, so there'll be some kind of horizontal shift, but that's okay because we're just typing it all in. Now, when I type in all this data, I'm going to make L1 the days of the year and L2 the hours of daylight that that year has. So if I go into my calculator here, to get to where I have to type in all my data, I'm going to hit stat. And you notice on the calculator, the button that I previously hit will pop up in red. So then I'm going to go to edit. You probably have some stuff in here from what we did in class. You can either clear it or you could just go right over the data, right? Delete every number that's in there, however you want to do it to get these to be cleared out lists. Now, I need to type in my data. So I'm going to type in 0, 50, and in this Y1 column, I'm going to put in everything that was in that number of days of the year line in my table. Careful when you're doing this not to miss a piece of data or type one in wrong. Make sure you double check. Another easy thing is if you look down here on the bottom, it says L1 and in parentheses it says 9. That tells you that there were 9 pieces of data that you just typed in. So if I check, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So that's kind of a quick check as well. If I go over to L2, L2 is going to represent the numbers of the hours of daylight. So we just type these in. Again, slow is better than fast with making mistakes. I know it seems tedious, but it does give us the answer without having to do a lot of work. So yay, calculators. Another thing to check is you should have the same number of digits in L1 that you do in L2. If you don't, there's a mistake there. All right, so now I have all my data in. So what I'm going to do is go into stat, go over to calculate, because now I want to calculate something, and I want to either scroll up or scroll down until I get to sine regression, and then hit enter. Remember, the iterations part we don't need to worry about, just leave it at 3. Period, we do have to type in. So if you have the new calculator like I have here, it's kind of easier setup. You just have to type in the 365 there. To get the regression equation where you want to store it, remember it's a variable, so we'll go to vars. It's a y variable, so we'll go to yvars. It's a function, so we'll go to function, and then hit y1. If you don't do this part, you still will get your answer, you just won't be able to graph it. We want to be able to graph it so we see what it looks like. And if we go down to calculate, we can hit enter. Now, if you're somebody that had the old calculator, what your screen will look like will be this without the 3 in it. So you don't need to put the 3 there. So you just have to type in your L1, comma, L2, comma, 365, comma, Y1. It'll give you the same answer. Now, since it is a regression, depending on how old your calculator is, you might have decimals like in the 4th or 5th decimal place that are different than mine over here, but rounding to nearest 10th or 100th should be exactly the same. So just keep that in mind. Like we did in class, let me just snap a quick picture of this so I don't have to keep clicking back and forth. All right, so now that we have that, oh, that's huge. Let me fix that real quick. So once I look at all of that, I could then figure out, well, what is my data really telling us? So it tells us to round to nearest hundredth, so it's 2 decimal places. It also tells us that we're talking about a function of hours with time. So we'll say h of t, hours in reference to time, is equal to 8.40. That second 9 makes this 9 round up, which in turn makes the 3 round up. Rounding, I know you haven't done that in a while. Sine of 0.2 t minus 1.38 plus 12.09. So what this function represents is a function of the number of hours or of daylight in each day of the year. So if I want to figure out how many hours are going to be in the 315th day of the year, I can just type in 315 for t. If I wanted to know how many hours of daylight approximately would be in the 12th day of the year, I could type in 12 for t. So that's what this function allows us to do. Now the interesting thing is if you go back into your calculators here, and I did this with my accelerated group, but I didn't do it with my Regents group. So if you're a Regents kid and you want to just follow along with this, it does kind of help a little bit. So if I go into stat plot, so if I hit second, y equals, and I turn stat plot 1 on, what's going to happen now is when I graph this, all of the little scatter plot points are going to come up, and we could see how good our regression equation was. So I'll start by hitting zoom 7 for trig. Notice I'm not going to see much of the graph because those numbers were so big. So then I can change my window. So the y values represented the days of the year. So I'll start with 0 because I can't have negative days of a year. And I'll go up to 365. And the y values represented the number of hours of daylight. So I could go from, I don't know, say like 0 to 24, because there wouldn't be more than 24 hours of daylight in a day. And then we can go through and hit graph again. So what I should see is all my points. Those are all the square dots. And then my function is going pretty much through all of them, showing us that this was a good model for the data that they provided for me. So let's keep going. So for number 2, we don't actually have to do the whole regression thing in the calculator. I'm just asking you to examine the function like we did in the first example in class, determine some of the things, and write a cosine function. So it looks like the minimum value is 0. And it looks like the maximum value is 1. Meaning 0.5 should be my midline. Now from all of that, I have a lot of info, right? I also have a period. Now it looks like it goes out to 31 here, but this looks like it starts at 1. So the period in time from 1 to 31 is 30 days. So approximately 30 days will give me a full cycle of this moon's surface illumination. So I know that the period is 30. Therefore, the frequency is 2 pi over 30, which is pi over 15. This looks like an upside down cosine curve, so a negative cosine curve. The amplitude is 0.5, so to get to 1 from a half is 0.5. To get from a half to 0 is 0.5. So I know it's negative 0.5 cosine of pi over 15x. It does tell us to use x, so we'll use x here. Plus the midline, which was 0.5. This is something that you should be able to do for your test or quiz. It then says a moon is considered a gibbous moon if more than half of it is illuminated. So since the y-axis represents the amount of illumination on the moon, we're trying to figure out the period of time where the moon is going to be illuminated. So if I take 30 and cut it into equal parts, I'm going to go halfway at 15. So 15 from 1 is about 16, so that should be the halfway point. Halfway between 1 and 16 is about 7.5, which we can even estimate to be about 8-ish. And halfway between 16 and 31 is going to be about 23.5, which we can estimate at just like 24-ish. So if I look at my function, above 8 and above 24, this red part of the function, that whole segment of the graph is above 0.5. So this moon is considered a gibbous moon from the 8th day, approximately, to the 24th day. Or we could say from the x value from 8 to 24. The last question looks super overwhelming, but it's actually easier, I think, than the other two, other than looking at some of the decimal parts here. So it gives us all this information about what this graph is talking about. I'm just interested in the graph at this point, right? I know we're talking about speakers and music or whatever, but I'm really just looking at what is this graph doing. So I see a ton of cycles of this function. I really just want to know how long it takes to make one of them. So if I start at 0 and go up and follow the curve, back down and end, that's one cycle of the function. Notice it doesn't end at a nice point. So what I could do is keep going until one of these cycles end at a nice point. But if I look, none of them do. They all end at like halfway points. So I'm gonna have to do some estimation here. So I got to figure out, what do each one of these little lines mean? So between 0 and 0.4, there's 1, 2, 3, 4 lines. So each one of those is representing 0.001. So it looks like it's a little bit more than 0.002 to complete a full cycle. So what I'm going to say here is that the period, and again, this is an estimation, is 0.0025. So about halfway between 0.002 and 0.003. It's not really halfway, but that's a good enough estimation where we're good. Now, if you really wanted to get good, you could count up how many full cycles I see, and then divide the total number of cycles by the total amount of time it takes for this to come out. It's going to give you almost the same answer. So that would be a lot of extra work for really no reason. So I know the period. I know the amplitude, because it's starting at 0 and going up, and then starting at 0 and going back down. So it goes up to about 1 and down to about -1. So the amplitude is 1. The midline looks to be about 0. So we should be able to come up with an equation for this function. So the first part says, does it seem more natural to use sine or cosine for this function? I'm going to say sine. And the reason why is because it starts at the midline. It would just be easy to represent this with a sine curve. Doesn't mean we couldn't represent with a cosine curve, but we'd have to do some type of horizontal shift, which we don't want to do. That just makes more work for us. So let's talk about an equation. So I know that the period times the frequency equals 2 pi. Well, we just estimated the period as 0.0025. If your estimation is different than mine, it's okay. You're only going to have one number that's different. If I divide 2 by 0.0025, I get 800. So the frequency is going to wind up being 800 pi. So my equation is going to be, and this uses different variables here. So it's I of x, intensity as a function of time or x. And since the amplitude was 1, I could just start by writing sine. It was a regular sine curve. It went up first, so it's a positive sine curve. The midline is 0, and we can just say this is approximately 800 pi x. If you use a different number for period, this number 800 pi might be slightly different. Like say, for example, you thought it was 0.0022, which is totally a good way of representing it. You're just going to have like 909 pi there instead of 800 pi. It's totally fine. There's kind of some room for human error here. Okay. Hopefully this video helps. If you didn't really get the last question, I would think that's maybe a little bit above Regents level. That's totally fine. It was more of a challenge question. The first two, especially number 2, this question we should be able to do. Okay, that's right on par with what the level is that we want to try and get you to be able to accomplish for this class. Don't forget about your take-home quiz. Remember, they're due on Monday. If you have questions, just email me or come and try and find me at some point during the day, either tomorrow or on Friday, so that we can go over it if you want to. Just remember, come with actual questions. I'm not going to just sit down and do it with you. All right? Good luck. Hopefully you're watching all these videos and start studying for that test.